Advanced Maths, Paper 1, 2021, Question 12, Memo with Explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself. So here's some suggestions for effective revision. Don't practice questions which you firmly know that you could do. Rather select questions on topics where you know that you will have difficulties. The only time you start practicing full papers is when you're trying to reduce your time taken to do the paper. If you become stuck at a question, yes, watch the video. Then it's vital that you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise maths is quality as opposed to quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately, without having to refer to help of any form, than to complete as many papers or exercises as possible. Confucius summed it up. What I hear, I forget. What I see, I remember. What I do, I understand. Okay, so we're going to do some integration now. We should recognize this as a special integration. We can't just do it by any of the methods, by parts or by substitution, and this isn't a straight one integration. So we've got to revert to our knowledge of trigonometry. Luckily, we have the formula involved to be able to do these on the information sheet. There's the formula I want. Sine A cos B. A is 5x, B is 4x. And I just substitute into that formula, which gives that. I can take in the half and split the integrals. And there we are, done either by K method or by inspection or by using substitution. Integral x e to the x dx. So I ask the question, is x the derivative of the inside function of e to the x? Of course, the answer is no. Have a look here. If this was x squared, this would be simple because then that would be half the derivative of the inside function. But it's not, that's x, so this isn't the derivative of the inside function, no. So we can't use substitution. So it's likely to be parts. And now remember parts, we start with a function and then the derivative of a function. X, u and du. dv, sorry, u and dv. Here we are. Integral u dv equals uv minus integral v du. So u dv, integral u dv equals, that there, equals. Now u we know is x. V, well, we only know dv, so we can integrate it to get v. So there we are, integral of e to the x dx is e to the x. I'm not worrying about the c here, I'm just showing you to be part of the formula, and we won't put it into the formula, the c, anyway, at that stage. And then v there, well, we've already used the v there, and du, which means we need to differentiate u, which just gives us 1. So, x e to the x, there's u dv. Sorry, there is uv, that's u dv there. U and v, there we are, u and v, minus integral v du. Well, du is 1, and v is e to the x dx. This becomes the integral of e to the x dx, which is just e to the x dx. It's just e to the x and plus our c. This one here, we can see a substitution because sine squared 2x there is part of the derivative of the inside function tan 2x. E to the tan 2x. This is a constant function, chain rule, outside function e to the something, inside function tan 2x. And sec squared is the derivative of sec squared is the derivative of tan. So I'm going to, it's likely to be substitution, so I'm going to let u equal tan 2x, which means I can then write e to the u later on. Now what I need to do is sort out this whole part with dx, and I want du instead. So we start by saying du dx equals outside function sec squared 2x times derivative of the inside function, which I've just neatened up. Now I don't want dx's, I want just du. So let's take the dx up to there. There it is there. So now if I can have that written there, then I can just put du instead. It's not quite right yet because there's no 2 there. But I can put a 2 there, factor of 2, and just put a half on the outside. There we are. Half of 2 is still 1, so it's correct. Now I have 2 sec squared 2x dx, just what I need. So instead of that, I can write du, and instead of e to the tan 2x, I can write e to the u. This is really easy to integrate because the integral of e to the u is e to the u plus c. So we'll have half e to the u plus c. Now we need to substitute back the tan 2x instead of u. So there we are. We have a fraction, and the degree of the numerator is greater than the degree of the denominator. So we're going to do it by partial fractions. But because this is the case, the degree is higher above, we have to divide first. So I'm going to do the long division. There we are. X squared minus 1 into that. So I'll say x squared into x cubed goes x, and then I multiply. I subtract, and then I bring down. I cannot divide any longer, so that's the remainder. There is the answer. So therefore it's equal to x plus x minus 3, still to be divided by x squared minus 1. So I'm going to take this alone, and I'm going to say that's x minus 1, x plus 1. Let it equal a over x minus 1 plus b over x plus 1, the partial fractions. If x plus 1, for example, was squared, we'd have to have x plus 1 and x plus 1 all squared. But it's not. This is a straightforward one. Now I want to equate the numerators once I have a common denominator. So I'm going to find a common denominator. Now that is equal to that. I don't need the denominator any longer because they are the same. Now I'm going to get rid of b by substituting 1 for x and find what a is equal to. Then I'm going to get rid of a by substituting negative 1 for x and solving for b. So substitute x equals 1. So therefore 1 minus 3 is minus 2. 1 plus 1 is 2a, and 1 minus 1 is 0, so there's a 0 there. And that gives me a is negative 1. Now I'm going to substitute negative 1. So that one goes out, it's 0. Negative 1 minus 1 is minus 2b, and it's equal to minus 4, which means b equals 2. I can substitute now back into that first line. 1 over x minus 1, minus 1 over x minus 1, there's my minus of the 1, plus 2 over x plus 1. Now these are very straightforward. Integral of x is x squared over 2, and these are both from ln. Ln x minus 1, ln x plus 1. So x squared minus ln x minus 1 plus 2 ln x plus 1 plus c. These are really chain rule, but the inside function is x minus 1, so the derivative is 1. Derivative is 1, so there's no complication there. If this was 2x minus 1, then I'd have to have a half there. Because when I differentiate, that's if it was 2x minus 1, I'd have the 1 over x minus 1 times 2. Okay, looks very scary, but it's not really. It's just to test you. The arc length of a given function f of x from x equals a to x equals b is the formula. Integral from a to b of that formula dx. Now that's true, in fact, that is the formula, the arc length, but you don't have to know that, you're just going to use this. Given the function f of x equals 2 root x cubed plus 1, you've used this formula to find the arc length from 1 to 12. So I'm going to find the integral from 1 to 12 of 1 plus the derivative of that all squared dx. So f of x equals 2x, the 3 over 2 plus 1. F prime of x equals 3x to the half. Multiply down by 3 over 2, the 2's cancel. Subtract 1 off the 3 over 2, we have a half. The 1 goes. F prime of x all squared, so I'm now going to square that, and I'm going to get 9x. Just doing the work on the sideline first. So therefore, I have integral from 1 to 12 of 1 plus 9x to the half instead of square root. That is now an inspection or K method or substitution. This becomes 3 over 2 because we're going to add 3 to it. When we differentiate that, there's the 9 inside functions derivative, which multiplies, so I have to allow for that. That's why K method is quite useful. But that is the integral of that. Now all I'm going to do, this is a definite integral, therefore I don't need the C. I'm going to substitute 12 into there, minus substitute 1 into there. And there is our arc length.